And in here, in the unstimulated parietal cell, we have tubulobesicles, which I'm gonna draw in green. And then we have our mitochondria. And in the tubulobesicles, we have the secretory machinery, which has the hydrogen, potassium, ATPase. And we have very few microvilli here. They're not very, you can't really see them in the unstimulated state. But in our stimulated state, our parietal cells look a little bit different. Oops. They have a lot more surface area. This is a lot more microvilli. And our tubulobesicles actually come to the surface here. This is where we have the hydrogen potassium pump on the tubulobesicles. And we still have our mitochondria. And yeah, so we have our microvilli has expanded in the stimulated state, as you can see from these little lines we drew. And these ATPase pumps come to the surface to easily secrete HCl. The moving of the cellular machinery, we call it, moves to the apical end, which is right here. And gastrin promotes acid secretion and histamine release by the G cells and ECL cells. So remember that during parietal cells. So if we have, I drew these receptors here, and we're gonna have, let's say, gastrin come in here from G cells, and that can promote the ECL cells to release histamine, which will promote acid secretion. Histamine. So more acid secretion from the more surface area we have, and yeah. So from the acid secretions we have from our parietal cells, about how we get these acid secretion, it's 10 minutes after a meal or stimulation, so that when we see food, hear about food, talk about food, 10 minutes after that, acid starts being secreted. And the stomach acid is almost always isotonic to plasma, and the stomach our stomach is acidic due to the hydrochloride. The process of formation of the stomach acid is currently unknown, so we're not sure about the mechanism. But how we get acid, we do know. So there is a bicarbonate and chloride antiporter at the basolateral end. So if we see this here, there will be we have bicarbonate coming out, chloride coming in, and then we have a channel here at the apical end, and that chloride is coming out. And we'll also have a which we already had on the parietal cells, which we already drew. We had the hydrogen, proton, potassium pump. And then this bicarbonate is formed from CO2 and water. But important thing to know is the bicarbonate chloride antiporter and the chloride channels. So once these two are in the lumen, this makes the acid, the hydrochloride. And then we have the water passing through paracellularly. It can go through without any channels. And also it's in the stimulated and the non-stimulated state, we have the ionic composition changing with the production rate of the acid. So the non-parietal obstruction, so the non-stimulated state, the tonicity is at a low rate. The sodium chloride and potassium are at similar concentrations to plasma. Sodium is slightly lower than plasma, and the chloride and potassium are slightly higher than plasma. There's little protons and tiny amount of bicarbonate in this state. And then once it's stimulated, we're at a higher rate of production. The parietal cells are contributing to these secretions, and there's more protons and chloride are being added. And it's said that sodium might be removed, but still not positive, which is the reason why they might have said that solution is slightly hypotonic. It's due to the sodium removal. So we have to have a way of regulating our acid secretions as well. And it's important to know the 3 phases of these acid secretions. So we have the cephalic phase, we have the gastric phase, and the intestinal phase. So the cephalic phase is the secretion of acid when there's the sight, taste, smell, talk of food. It's about 30 to 50% of total acid secretion responses. It's responsible for that. It's mediated by vagal innervation, and it can be blocked by acidification via negative feedback, which I will show you a diagram of in a second. And then the gastric phase, that's when the food enters the stomach. It's also blocked by acidification. And there's 3 components that increase secretion. We have the vasovagal reflex, which is on the G cells and the parietal cells. The G cells secrete gastrin, and the parietal cells are secreting acid. Also the intrinsic stretch reflex, which stimulate the G cells to increase gastrin. And also we have the peptides, which stimulate G cells as well to secrete gastrin. So all these 3 involve the increasing of gastrin in that gastric phase. And then we have the intestinal phase, which is when our food is in our duodenum. It's unclear on the stimulation of acid, but the proximal duodenal may release acid secretion. Also, we know that gastric emptying will inhibit acid secretion if chyme has less than 2 pH. If there is fat, distension, hypertonicity, also being mediated by gastric stomatostatin, CCK, or GIP. So I have some of these written down, the inhibition of acid secretion that we were just talking about right here. So the chyme has to be less than 2 pH, fat, distension, hypertonicity, somatostatins, CCK or GIP can inhibit acid secretion. It's also, the inhibition is mediated by factors binding to the somatostatin receptor. The somatostatin from the D cells and the bombasin, which is unknown where it's coming from. We will talk about the bombasin in another slide. Also, it's important to know that inhibition is directly on parietal cells and G cells, and indirectly on the ACL cells. The ACL cells, it's indirect because it ends up decreasing the histamine secretion, so that inhibits our acid secretion as well. But I do want to show the blockage of acidification by negative feedback and all these happening at once, so you see the big picture. So I didn't draw the best picture, but you guys will get the idea here. So we have a stimulus here, or from the visceral efferent neurons that go into the DMX center, and then that goes to the parasympathetic nervous system preganglionic neurons, the vagal nerves, and then that goes in the enteric neurons, which can excite the ACL cells to release histamine on the parietal cells. This is the parietal cell right here. Or they can release the G cells, they tell the G cells to release gastrin, which that hits on the histamine, and then histamine secretes